Today talking about astronomy and how astronomy relates to some of the things that you're talking about and considering. Astronomy is really the science of studying the universe and all the aspects of the universe, which include the stars, galaxy, and our own solar system. As I mentioned to you once before, the study of astronomy started many years ago, back in the Middle Ages, with the discussions by Galileo, Copernicus, and Kepler. And they discussed things having to do with the development of the universe, particularly the general observations that they made with the human eye and telescopes. But with the advent of astronomy nowadays, we have telescopes that could extend into the universe, and we could see things like nebula, and etc. Now, why is this related to physics? It's related to physics because physics is just part of the study of astronomy in the universe. There's also biological matter, chemical matter, and basically the universe is drawn together by the laws of motion and gravitational forces. For example, the gravitational forces that we've recently studied, bringing planets together, holding galaxies together, and as many of you know, our solar system is connected by planets, but it's all part of the Milky Way galaxy. Now, there are billions and billions of stars in the Milky Way galaxy, and then billions and billions of galaxies. I don't know if you remember Carl Sagan. He was a kind of a famous, lecturer and astronomer, and he talked about the billions and billions of stars in the universe and how the universe is expanding. But we have to remember that people like yourself who are studying science, that it's made up of gases, it's made up of connecting magnetic forces, connecting electrical forces, connecting gravitational forces. There's also chemistry. There's a lot of gases in the universe. There's a lot of gases in our own sun, for example. So when we talk about the universe, and we're talking about galaxies, for example, if we look closely at galaxies of this kind, there's different kinds of galaxies. There's spiral galaxies, there's galaxies that are flat, but the universe is billions and billions and billions of light years in extension. And it's always expanding. So it's sort of mind-boggling. And to our knowledge, human beings made up the physical, chemical, biological, and makeup of a human being. We're the only known human species in the world, in the universe, that they know of. The scientists, of course, now are studying the universe. In fact, the physics and astronomy department here at George Mason University has an extensive research element where they're studying galaxies and stars and novas and supernovas. So it's really a very exciting field, and there's a lot for us to understand in astronomy. Just the study of the sun, for example, which is one of the biggest stars, which you never think about, especially you never think about we take it for granted that the sun's there every day, that it's emanating energy, and actually there's thermonuclear explosions occurring every second, according to Einstein's theory, converting mass into energy. We never think about that, but remember, in our own little simple universe, which is our solar system, the Earth and the planets and, the sun, and us revolving around the sun, that's just one aspect of this huge universe, which is made up of physical, chemical, and biological mechanisms, which many of you now are studying. But it's all one of the natural sciences, and you cannot isolate your studies of chemistry and biology and physics from this huge natural phenomena that is the universe, which started like 13.7 billion years ago and is still growing and expanding, and we're looking at marvels of thermonuclear explosions occurring every second, converting mass into energy, and occurring in billions and billions of stars. You and I take it for granted that the sun is always going to be there, but actually, in fact, someday it will not be there. But fortunately, it's going to be billions of years, maybe 100 billion, 200 billion years from now, and we probably won't affect us. So it's not something you have to be concerned about every day, but it's a phenomenon that's happening. So if you could imagine in your own minds, billions and billions of thermonuclear explosions occurring every second. Every second. It's unbelievable, really, if you think about it. So it's something that at least in your studies of physics and science, you should kind of at least get some feeling for and some understanding. And the study of astronomy has to do with the study of all of these aspects of the universe, and including things like the Earth's atmosphere, including phenomena such as star clusters. Sometimes when you look up in the sky with a naked eye in a dark evening on a beach somewhere, or where there's not too many lights, you'll see stars. Some of them don't even exist because they're billions and billions of light years away, and they could have disappeared. So stars are coming into being, stars are dissipating, and stars are kind of dying off. Some of the things that you see in the evening sky no longer exist because it takes billions of years for the light to get here. And when we talk about light, that's an electromagnetic phenomenon. When we talk about the gases that surround stars, as could be observed in this particular picture, we're talking about chemical processes. And when we're talking about life on other planets, there's biological life that exists because there is some water on other planets and things of this nature. So the study of astronomy is the study of life itself, and the study of the universe, and the study of natural phenomena, which are really, just as people, we kind of should understand it and appreciate it, but as scientific people, we should really consider it in our everyday lives and in our professional lives. One of the things, of course, that many of us are familiar with is the solar system, which is the planets revolving around the sun. The sun is constantly in thermonuclear explosion, so it looks reddish and yellowish. And what we see is a light, which is an electromagnetic wave, coming from the sun. And for years and years and years, which many of you may know, scientists like yourselves said that the planets or the Earth revolved around the sun, but I guess, it was not accepted either politically or religiously. So the people like Galileo were contradicted, abused, put in jail because he said everything revolved around the Earth, and people were, egocentrical. They didn't want to feel that there was something, some other force in the universe that created the solar system. They felt that man was responsible for all of that. So it wasn't religiously or politically acceptable. But later on, people like Kepler and other scientists. Now, I mean, when I say later on, I'm talking about the 15th and 16th centuries. So that was, 400 or 500 years ago. They just began formulating the postulate of how the Earth rotates around the sun, how the moon rotates around the Earth, all having to do with things that you're studying in this class. Gravitational forces, conservation of energy, momentum, harmonic motion, wave theory. And so it's interesting for us to look at all these aspects of astronomy and kind of keep it in perspective. Right. I wonder how that came out. I don't know. Did it come out at all? I guess.